Alright, this is your material setup and procedure for the Speed of Sound Lab. As you can see here, you got a laptop. The laptop is connected through a USB cable to the green LabPro box, and the LabPro box is plugged in down here. And then coming out the bottom right corner you see the probe for the day, which is a microphone. These microphones are expensive, so please be careful with them. You also have a rolled up cardboard tube and then a meter stick. Now the whole point of the meter stick, you're going to have to measure how long the tube is so that you know how far the sound travels down and back. So by the time you get into the lab this morning, the entire material list should be set up for you, so all you need to do is log in. When you get to the main desktop of the computer, you're going to look for Logger Pro, which is that symbol that looks like this. Click on that and open it up. One thing you want to make sure is that the green collect button is green. If it's not, call your teacher over. Now, you're going to click on the open file icon because you need to find the file for the Speed of Sound Lab. So you click here. Go down to Physics with Vernier, the one at the bottom. Open that folder. Go all the way down to the bottom of the list of files and find Speed of Sound right here. And open that file. And it's going to look just like this. Now, this file is set up so that when you snap your fingers or make any kind of sharp noise in front of the microphone, it'll start collecting. So when you're not collecting, it's important that you be quiet for other groups, otherwise you're going to throw their results off. When you get it set up the way that I'm going to show you to, then you snap your fingers in front of the microphone, but only after you hit collect. So you would click on this green button, and then when you snap, you'll see a wave pattern like this come up. Now sometimes the wave pattern goes on or off the graph, so if you click on this capital A button, it auto scales the graph. Like so. So you can see it a little better. Now this is a very bad waveform because you can only see the wave pulse in the middle here. This is from the snap, and if you get a good waveform, what you're going to see is a big pulse like this for the snap, and then another one over here somewhere for the echo. So you may have to do this more than one time. That one's a little bit better, not very clear, so I'm going to do it again. Getting better, still not very clear. Like I said, you may need to do this a couple times, and it'll be obvious when you get a good one. Alright, that's a good one. You've got a clear echo peak right here. So the two places you're going to look at are this first large spike and the second spike, which is the echo of the sound going down and back. This strange hump in the middle here before the first spike you can pretty much ignore. So what you want to do is you want to figure out how much time goes by from here to here, and I'm going to show you how to do that now. First you want to auto scale it a little bit, and then you want to click on this big capital X equals button. It allows you to examine detailed information on the graph. So you want to find the highest point in the second pulse, somewhere right about there. You can see that little circle here is sitting on the peak that you want. That's the maximum for the second pulse. And if you look up here, it says the time as 0.00918 seconds. You would record this as T2, or your peak 2 sound. Okay? Then you want to go back to the first peak. This is where you actually snapped your fingers, and that's going to be up top here. So you can drag that box out of the way if it's in your way. When you get the dot where you want it, like so, then you're going to record this time. And you can see it's 0.00600 seconds. So you can get pretty precise with these microphones. That's your snap finger time, or your T1 time. And then you're going to take the difference in those two times, to figure out how much time it took the sound of your finger snap to go down and back. There you go. Now, to see it all again, I'm going to put a video of me actually doing it, and you're going to see it side by side with the data. Alright, here's me on the right. Now you take the microphone and you put it right at the top of the tube. One thing I want to point out, and you can see me doing this with my hand, you want to put the microphone right at the opening of the tube. You don't want to stick it inside the tube, and you don't want to have it out past the tube, otherwise you're changing the distance that the sound travels. So when you're ready, you snap your fingers, and you'll see a waveform like this pop up. And that's all you need to do. I look kind of silly frozen in time there, but that's really all you're looking for. That would be one full cycle. So back to the data. You got your snap and your echo. You got to do 5 good trials of that, and then you're going to calculate the speed of sound for each trial. And then when you're done, you're going to take the average. And that's really all that you need to do for this lab. One thing that you might want to make sure of is that the person who's snapping their fingers has a really good loud snap. Otherwise, you won't be able to hear it, and your data will be unclear. The other person that needs to be involved is the person who's going to be hitting collect on the computer to collect the data. You could have a recorder write the numbers down, and you could have a 4th person doing the calculations. That way, you'll get the lab done very quickly. That's it. Good luck.